Bismillahirrahmanirrahim. In Unit 4, we will discuss about analog versus digital signal. These two types of signal are the backbone of modern communication system and technology. Let's start by understanding what different them. Analog signal are continuous and can take any infinite range of values within a given range. These signals are typically represented by smooth, uninterrupted waveforms, making them ideal for representing real world phenomena like sound, temperature, or light intensity. On the other hand, digital signals are discrete. They consist distinct value of typically represent as binary values 0 and 1. Digital signals are more robust against noise and interference, which make them essential in modern computing, digital communication, and multimedia systems. Understanding the differences between analog and digital signal is crucial for communication because how data is transmitted, is stored, and processed, it depends on the nature of the signal itself, either from a radio broadcasting to a modern digital communication system. Let's take a closer look at both type of signal and their application. This unit 4 is a continuation of chapter 1 communication system and basic building blocks. As we have already discussed that we are going to dive deeper and discuss the signal types such as analog signal and digital signal, their importance, their comparison, used in these building blocks for successful communication systems. We are going to explore one of the most essential concepts in electronics and communication, the comparison between analog and digital signal. These two types of signal are the foundation of how information is transmitted and processed in virtually every technology we use today. Let's start with analog signal. Analog signals are continuous, meaning they can take on an infinite range of values. These signals are typically represented as a smooth waveform where the information is encoded by the amplitude, frequency, or phase of the wave. Think of analog signal like sound waves where every detail of the sound is captured by its continuous version. One key characteristic of analog signal is that they are susceptible to the noise. Noise can distort the signal, causing degradation in the quality of information being transmitted. Additionally, over long distance, analog signal can lose their integrity due to this degradation, leading to a loss of data clarity. For example, if you are listening to an analog radio station and you move too far from the transmission tower, you may experience static or poor sound quality due to signal degradation. Now let's move on the digital signal. Unlike analog, digital signals are discrete in nature, meaning that they transmit data in binary form, either as a 0 or as a 1, and their combination. These 0 and 1 represent or presence or absence of a signal at a given point in a time scale. Digital signals are not only simpler to manipulate and process, but also for more resistance to noise compared to the analog signal. Even if some noise interferes with the digital signal, as long as the noise is not too strong, the signal can be reconstructed perfectly at the receiver. This is because digital data or signal is made up of distinct, clearly defined values, unlike the continuous variation of analog signal. The main advantage of digital signal lies in their ability to maintain signal integrity over a long distance. Digital signal can be easily regenerated along the transmission path, ensuring that the original information is preserved even for a very long distance transmission. This is one reason why technology like the internet, satellite communication, and cellular network rely heavily on the digital signal. However, while digital signals are more robust and against noise, they are not always ideal for representing real world phenomena. Analog signals are often better and capture subtle nuances such as natural tone and quality of the human voice in audio recording or the smooth variation in temperature measurement. In conclusion, both analog and digital signals have their unique strength and weakness. Analog signals excel in representing continuous, well real world data, but they are more vulnerable to degradation. Digital signal, on the other hand, provide greater reliability and noise resistance, making them the preferred choice for modern communication systems, especially over long distance. As technology continues to evolve, the use of digital signals is likely to expand even further. But understanding both type of signal remain crucial for analog signal as well as digital signal for working in electronic or communication. In this slide, I would like to talk about the advantages of analog signal and how they play a key role in the world of communication and data representation. I will focus on the main benefits of analog signal, such as fidelity, simplicity, and real-world presentation. Firstly, we discuss about fidelity. Analog signal excel in capturing the variation of real-world phenomena, whether it is richness of the live orchestra or the intricate color of a photograph. Analog signal can convey the original form with very high precision. Their continuous nature means that do not lose any type of information between discrete points like digital signal sometimes. This is why audiophiles often prefer analog vinyl record over digital music. They value the warmth and depth of the analog provides. Similarly, we discuss about another advantage as simplicity. Analog systems are inherently simple in nature than their digital counterpart in many aspects of application. They do not require complex encoding or processing to operate, making them straightforward to implement and maintain. For example, traditional amplitude modulation or frequency modulation broadcast work directly with analog signal, avoiding the need of costly and energy intensive energy digital conversion process. This simplicity also make analog system more robust in certain situations, such as in low technological environment or under extreme conditions. Finally, we will discuss about the advantage of signal in terms of real world presentation. The physical world around us operate in an analog manner. Sound, light, temperature, even our biological signals like our heartbeat, all are analog in nature. Analog systems are preferred, suitable to capturing and replicating these signals because they mirror their continuity. A microphone, for instance, directly converts sound waves into analog electrical signal without breaking them into binary code. This direct representation ensures a smoother and more accurate representation of the reality. Now I want to highlight the advantage of digital signal, particularly with noise, immunity, data compression, and error detection and correction. These qualities make digital system a cornerstone of modern technology and communication systems. Firstly, we discuss about noise immunity. Digital signals are far less susceptible to the noise compared to the analog signal because they represent data in discrete value, either 1 or 0. Even if noise distorts the signal slightly, the original data still contains the shape close to the 0 or 1 and easily recover accurately. For example, in digital audio or video streaming, a strong interference might degrade an analog signal quality, but the digital system can reject that noise and deliver the clear output. This makes digital signal ideal for long distance communication like satellite transmission or internet data. Secondly, we discuss about data compression. Digital signal allow for advanced compression technique, enabling the efficient storage and transmission of data. For example, MP3 for audio and MP4 for video reduce the file size while retaining very high quality of our either music or our video files. These compression capability is why we can store thousands of the thousand songs in a small device or stream high definition video with minimal bandwidth. Without this advantage, modern communication system from cloud storage to video conferencing would be much less practical. Finally, the error correction and detection is another advantage of digital signal processing. Digital signal can detect and correct errors during transmission using technique like checksums, parity bit, and error correction in code. Digital signal can be identified if data has been corrupted and restored to its original values. This ensures reliable communication, which is especially critical in the field like aviation, medical devices, and banking, where accuracy is non negotiable. For example, when you download a file, digital error correction ensures that file you receive is exactly what was sent, even if part of it got disrupted, but still it can recover and correct it along the way. Now we will like to address the disadvantage of analog signal and how they can limit their effectiveness in certain applications. Especially we will discuss noise sensitivity, signal loss, and limited flexibility challenges that have paved the way for the rise of digital technology. Firstly, we discuss about noise sensitivity. Analog signals are highly susceptible to noise and interferences because they operate on continuous waveform even though the slightest distortion, whether from electrical interferences, weather conditions, or poor equipment, can degrade the quality of the signal. Think of static on a traditional amplitude modulation and frequency modulation radio. As the signal weakens, the music or speech become difficult to understand. Unlike digital signal, which can reject noise to a large extent, we will discuss later on, analog signal are often lack this resilience properties. Secondly, signal loss. Analog signal tends to weaken or attenuate when they are passing over a long distance. As the signal travels through cable or airwaves, it gradually loses strength, leading to significant different degradation in quality. For example, in analog telephony, conversation over long distance often sounded muffled or distorted. Amplifiers can restore the signal strength, but they also amplify the noise, which is available in the analog signal itself, therefore further degraded the original signal. Finally, we will discuss about the limited flexibility. Analog signal lack the flexibility that digital system offers. They cannot be easily compressed, processed, or stored without risking quality losses. Modifying and analyzing analog signals often requires complex hardware and are the lack of programmability make them less adaptable in modern dynamic technology environment. For instance, editing an analog videotape is far more cumbersome and error prone than working with the digital video files, where precision and efficiency are the norm. While digital signals have revolutionized technology and communication systems, they are not without their limitations. Today, I will discuss the three notable disadvantages of digital signal: complex circuitry, quantization error, and higher bandwidth requirement. First of all, we discuss about complex circuitry. Digital systems require intricate and often expensive circuitry. Unlike analog systems, which can function with simple components, digital devices rely on microprocessors, logic gates, and advanced software to operate. This complexity increases production cost and demand specialized expertise to design and maintain. For example, a digital signal processor, which is DSP, in a smartphone is for often more intricate than the simple circuit used in analog radios, leading to higher manufacturing and maintenance cost. Secondly, the quantization error. Digital signal approximate continuous analog signal by converting them into discrete value during the analog to the digital conversion process. This conversion can introduce quantization error where subtle detail of the original signal are lost. For instance, in a digital audio, a low sampling rate may fail to capture the full depth of the musical performance, resulting in the loss of richness as well as accuracy. These errors are particularly noticeable in the system with limited resolution or inadequate sampling. Finally, higher bandwidth requirement. Digital signal often demand significantly higher bandwidth compared to their analog counterpart because they carry data as discrete packets. They require a faster transmission medium to maintain quality and speed. For example, streaming high definition video signal consume for more bandwidth than transmitting an analog television broadcast. This limit for higher bandwidth can strain network infrastructure and increasing cost, especially in area with limited connectivity.